Good afternoon, everybody, or good morning. Today, I want to talk about polynomial functions. And your learning target today is I can describe a polynomial by names, terms, and behavior in graphs. So there's quite a bit to do. And basically, a polynomial function starts with the highest power all the way down to the lowest power. That's what all that business is right there. A sub n times x to the n plus a sub n minus 1 times x to the n minus 1 all the way down to the a sub 0. That basically is like a function like if you had like x cubed minus x squared plus 2x plus 3, something like that. So just a few things. Um, Pretty much shape and continuity. If you were to talk about this, the cool thing about this is polynomials. Polynomials um, are smooth curves. What does that mean? That means they're smooth curves with no breaks or gaps. Okay, they are continuous for all real numbers. So what does that mean? That means that its domain is all reals all the time. Every polynomial has domain that is all reals all the time. Now, a degree A degree is the highest exponent a polynomial has. All right. So the highest exponent is the degree. All right. So like this guy right here, this is actually a degree of 0. This one is a degree of 1. This guy right here, there's a 2 there, so that's a degree of 2. This is the highest degree is 3. This one, the highest degree is 4, and this one, highest degree is 5. Now, all of these are written in standard form. Why are they written in standard form? Because they come from the highest to the lowest. So you look at this last one and see how it goes to the fifth, to the fourth, to the second, to the first, to the 0. These are all functions. These are all standard form. Okay? Now, a polynomial of degree 0, you should remember, is a constant. Polynomial of degree 1, well, that's easy. That should be a linear. Polynomial of degree 1 should be a linear. Polynomial of degree 2, you could say is a quadratic. Polynomial of degree 3, but you don't know what that one is. That one's a cubic. Polynomial of degree 4, that is a quartic. Not a wartic, but a quartic. And polynomial of degree 5 is a quintic. But you don't really need to know fourth and fifth degree. You can leave it as that. Yeah, that's fine. Quintic. All right. When we talk about the end behavior, you want to look at if the lead coefficient is positive or if the lead coefficient is negative. And this is exactly from the previous stuff that we talked about. So you can almost just copy that into your notes, but it's the exact same stuff. That is, as x approaches infinity, function approaches infinity. So just really seriously copy this from the other day. Don't need to deal too much with that. Okay. So examples using the lead term, give the end behavior of each polynomial. So this first one, well, the lead coefficient is negative. The lead coefficient is in fact negative. So as x approaches infinity, the function approaches negative infinity. So we're going to use that one, right? And then as x approaches negative infinity, the function approaches negative infinity. That's kind of like what we did before. For this one, the lead coefficient right here, this lead coefficient is negative and it's an odd. So this one has x, as x approaches infinity, going to negative infinity, and as x approaches negative infinity, the output, the function itself, goes to positive infinity. That is pretty much what we talked about in class on the first day of the new semester. So hopefully that makes sense to you, right? Number three, this guy's Lie coefficient is positive. This Lie coefficient is positive, and so in this case, you're going to say that um, x approaches infinity, the function approaches infinity, and as x approaches negative infinity, the function approaches infinity. That's because it opens up. Number four, this guy, as x gets big, the function approaches negative infinity, and as x gets really small, the function also approaches negative infinity. Because if you graph it, it's something like this, right? So you could probably do 5 and 6 on your own. It's not a big deal. If you look at number 7 and number 8 here, it says describe both powers and coefficient of the leading term of the polynomial given the shape of the graph. Well, this guy clearly is odd because this is like this right here. And so this is going to be negative. Why? Because the end behavior, this is as x gets really small, this is going to positive infinity. So this is odd, and it's going to be a negative coefficient. This guy is going to be even because it looks kind of like a parabola, and it's got, I guess you could argue it's got up end behavior, so it's a positive coefficient. All right. Now we talked about this before, critical values, and we talk about turning points. So like if I were to tell you this guy right here is a turning point and this guy right here is a turning point. So what is a turning point? It's where it switches directions. So if the higher turning point is if the turning point is higher than any nearby point, it's called a relative. Guess what it's called? A relative max. And if it's lower, it's going to be a relative min. Do you guys remember that? Yep. And then so we probably don't remember this, but maximum and minimum values are called extremas. So they're extremas, right? Those are extrema points. So turning points define where the function is increasing or decreasing. So that's kind of important. Now, this part, using the calculator to find turning points, realistically, if we were in a non-pandemic or if we were using the graphing calculators, we could do this, but I will show you how to do it using decimals. So the first thing you want to do is you want to open up decimals. And so I have decimals open, and you're probably not going to be able to see this part, but I'm just going to punch in y equals x to the third power. And I know it's cut off a little bit in the video, but you can just type it in, 5x squared minus 8x minus 1. And then now the nice thing with decimals is I can zoom in and zoom out, and if I need to get the relative maximum point, I'm going to have to go way up like this, and I can click right here. There's my relative maximum point right there. I'm probably going to say it's negative 4 comma 47. If I want to get my relative minimum, that's this guy right here. And you could probably say that's probably what, 0.67, negative 3.8, right? And when you talk about increasing intervals, this guy's going up from negative infinity to negative 4. It's also going up from this guy, 0.67 to infinity. And then from negative 4 to 0.67, it's decreasing. So you've seen that before in a previous previous section, a previous unit of study. So hopefully that makes sense. Okay, I want to move on to the next part, which is graphing polynomial functions, and you have the stuff there, but I just kind of walk you through it. The nice thing about it is they want you to classify what type of stuff this is. So if you look at the first one, the very first one we're going to do is that x squared plus 2x minus 5. Well, that's easy. That's a what type of thing is that? It's a quadratic, right? Its domain is all reals, and its range, it never falls below here. So its range is everything greater than or equal to negative 6. Now the relative min is this vertex at -1 comma -6. It has no relative max, and its increasing interval is from -1 all the way up to infinity. Its decreasing interval is -infinity all the way down to -1. The end behavior, the end behavior will be as x gets really big, the function gets really big, and as x gets really small, the function gets really big. So this is just like before from the previous section, right? If you wanted to look at the number 2, for example, if you want to look at number 2, right? Well, number 2, you have number 2. This one is -2 x to the third power plus 8x minus 1. That's a cubic, right? That's a cubic. Its domain is all reals. Its range is all reals. That's the nice thing about the odd polynomial functions. Its relative minimum is right here. It's not quite, I would not say it's that. I would say it's more like probably -1, -7. Its relative max, I'll probably zoom in a little bit. Its relative max is probably like 1 comma 5. I'm not going to worry too much about that. That's 1 comma 5. It's increasing interval. It goes up from right here from -1 to +1. It's decreasing from -infinity to -1 and from 1 to positive infinity as x is getting bigger, right? And its end behavior, well, since it's negative lead coefficient, x gets big as the function gets small, and x gets really small as the function gets big. So that's those. The next one you have, I believe, is a quartic polynomial, right? And you just use decimals to walk you through this. These are not super difficult to do in whatsoever. So take some time, maybe pause the video, work on these, practice using decimals, and I think you'll be all right. Okay, so I will definitely see you in class real soon, and may the force be with you.